Hello friends, in this session we are going to discuss about the trip logic and analyze that how the trip logic or operate logic works. Suppose we have a pickup, this signal is 1, then this 1 is supplied to AND gate, and the operation functionality is also on. It means it is yes on during our setting. We turn this operating functionality as a yes. This signal is also 1. Then the output of AND gate is also 1. This 1 is supplied to this SR latch. The S portion is latched, so the output is 1. Now this 1 signal, on signal means high signal is supplied to time delay block. This operate delay we gave this operate delay during our setting. Then the output becomes again 1 after passing this operate delay. For example, after 100 milliseconds, 200 milliseconds, we will discuss furthermore how much should we set these values. But right now, suppose 100 milliseconds, after 100 milliseconds, the output becomes 1, and this 1 is supplied to another AND gate, and another terminal, the B terminal of AND gate, is supplied from operate and fault record block. So if the fault record and operation is not blocked, it means during the setting this one is set to no. Then this one is also 1. The output of this functionality after AND is also 1. So after minimum operating time, the system will operate. It means an operate signal is generated. Now let's understand how this SR latch is resetted and how this reset signal is generated. As this block is this function configuration is already discussed in the previous sessions, we know that whenever the 3I0 RMS value and V0 fundamental value exceeds the threshold value, and after passing of 100 milliseconds a signal is generated. This signal is for picking up. This is a pickup signal, and also before going to the pickup, it goes to the transient ground fault records. And without analyzing, without having the information of the direction, because this signal comes from these two sources. One is from direction determination, and it is not containing any direction that to understand that it is forward or reverse, because this forward and reverse determination is done furthermore, and it is supplied to the pickup signal, not to the transient ground fault signal. Now suppose that these thresholds are exceeded, and after 100 milliseconds it goes to the block of transient ground fault. This one is 1. But due to a misoperation of this block, or suppose that this block could not analyze and could not understand which direction it is, so without the determination of the direction, this one becomes 0, and here it is 1, and when 0 the output is 0, so we don't have pickup, but we have a transient ground fault. Here we don't have a pickup. Here it is 0, and the transient ground fault, this signal is 1. And we know here it is inverted. It means the pickup is inverted, so another input to the AND is also 1. 1 and 1 becomes, the output becomes 1. And it goes to the R terminal of SR latch, so it resets. And this is due to the opposite or unknown direction of our pickup, because our pickup couldn't have a signal. It means we don't have any pickup, but we have transient ground fault. It is maybe unknown direction, or maybe it is in opposite direction, not in forward direction, because over there we had, for forward direction we had a pickup, and it starts to reset operate. It means it will not operate. And of course, if we have pickup, so this signal is 1, and the inverted part it is 0, so 0 and 1, this one is 1, because definitely we'll have transient ground fault detected, and the direction is also detected, so this one is 1 and 1, but the inversion part becomes 0 and 0 is 1, and it will not start to reset. And also it will reset if we have V0 fundamental and 3I0 RMS value exceeds the threshold, and after extension of the fault, this functionality of the block after extension fault, it is also to yes, it means it will block after extension of the fault, and the fault extension signal, this 2 becomes 1 and 1, the output becomes 1, the output becomes 1. Now the inversion part is 0. This 0 is supplied to this AND block, and it will not generate output, so it will not reset. But whenever the fault is not extinguished, and still the fault is there, so the output of this signal is 0, the inverted part is now 1. This 1 and also fundamental components and 3I0 RMS is also 1 and 1 and 1. The third, all 3 inputs are 1, so the output is 1. Now the output is 1 after the dropout delay. It means it passes after some seconds, for example 10 seconds, it drops out. It means then these thresholds are not exceeded, and the input becomes 0, so the output is right now when it passes the dropout, so the output is 1, and here the inversion is 0, so it will not reset. But whenever it passes, it does not pass the dropout block. It means after the dropout delay, it will goes to 0. Now the inversion port, it is a 1. This one will turn on this OR block, and it will reset our functionality. And we can understand now that whenever the dropout delay pass out and this threshold value reduces, so it reduces below the threshold values, it will reset. Or it may be due to unknown direction determination, or in opposite direction, it will reset. In the next session, we will discuss about all these values for transmission line settings.